Allison, I definitely agree with you that these slides are amazing. Shout out to Jamie, who designs the most beautiful slides. I really, really love the slide deck. So my name's Madeline, and I'm the energy storage manager at Soligent, and we're going to be talking about the grid. It seems like we're so used to the grid providing power to our homes all the time without a hiccup. And most of the time, it does just that. And it works very well. But live in Austin, Texas, and in our case with the winter storm Uri, that definitely was a wake-up call for a lot of people, saying that the grid is not infallible and we have to find ways to prepare for uncertainties. And I want to talk a little bit about where the grid experiences failure most commonly and why, so that we can talk about solutions to either improving the failure points or circumventing those problems so that we can just go directly to solutions. Okay. So we're going to talk first about transmission and distribution because that's really a key function of grids and how they work, and how they are the common source of failure that we're experiencing in the grid today. We'll do an overview in general on the power grid and how it's set up and what the electricity generating sources come from. And then why redundancy is a really good tactic for improving resiliency. Because when you are able to find multiple sources of backup to increase fail safes, we're able to have fewer problems. And then where are the solutions? How can we strengthen the grid today, make our power more reliable, and where are the solutions coming from Soligent? So just to talk about myself a little, my name is Madeline, and I am the energy storage manager at Soligent. I have been involved in the solar plus storage space for over 5 years, and it really has changed a lot. Recently, the grid tie battery backup storage space has gained massive momentum, I would say, in just the last 12 months. We have so many solutions that can provide backup power for your home, provide fully off-grid solutions, and more and more now, grid services are becoming a topic of revenue streams that batteries can provide. And we can talk about how grid services are related to grid resiliency. My goal is to support installers and customers by explaining how battery solutions work and understanding which solution is right for you, because there are a lot of options these days and it can be hard to decide what's the best. But I love talking about these topics, so feel free to introduce me to any of your end customers or colleagues that you think would like to learn about how to size a system or select which brand is appropriate for a given application. So I am connected to all of our different manufacturers, so we can connect anyone that you see fit for developing projects and making sure they go as smoothly and planned as possible. If we start by looking at transmission and distribution over the ages, let's back up to kind of the evolution of electricity. And originally, a long, long time ago, in the early 1800s, mid to late 1800s, let's say, DC power, direct current, was the original electricity source. So small electronics with short distances of transmission were powered from direct current. And the evolution of direct current into alternating current is what enabled transmission of electricity to go longer distances. So originally, this AC power was coming from hydroelectric dams. And so New England is a place that we can think about that often. So New York, and the larger hydroelectric plants with waterfalls and dams was the first source of major transmitted power. After hydro was implemented, coal-fired steam engines started coming into vogue. And the first power plant began operating in New York City in 1882, and that served up to 500 customers within its first 2 years. So then at the turn of the century in the 1900s, power stations started to take off. So if we look at a substation, our power is generated in this one site. We have transformers sending the power across these transmission lines. And then there are sensors to determine if we have the appropriate amount of supply and demand feeding. And this is a relatively simple concept, but in order to automate it more, it requires a lot of controls and communications. So the sensors controlling or regulating the supply side and the demand need is where a lot of innovation could potentially be coming. So this slide is from the EIA. So this is available to anybody, and it's actually an interactive slide. So if we evaluate from the beginning, if 1950 is where this visual began up until today. So back in that time, coal was the primary. By 1950, if let's pretend we're starting in 1900, hydro was first and then coal came along. But by 1950, so over those 50 years, coal already dominated with 155 billion kilowatt hours being provided, with hydro in second place at 101 billion kilowatt hours. So we're seeing coal really take over in that time. Natural gas was also a provider with 45 billion kilowatt hours, then with petroleum and in last place with 34 billion kilowatt hours. And in this chart, the green is renewables, and the green is distributing mostly hydro in this time. Renewables by 2020 are going to incorporate a lot more options, but in 1950, we're looking at renewables as mostly hydroelectric power. Okay, fast forward to 2020. This is just the green section. So if we look at the green section in 1950, then by the top, 2020, this is a major chunk. So what is making up the renewables segment now? Hydro is still 291. So honestly, it didn't grow a whole lot. From 1950 until 2020, we went from roughly 101 billion to 291. So we only added 100 billion kilowatt hours of hydro over that 70-year period. The biggest new contributors are wind with 337 billion kilowatt hours and solar with 91. But it's so crazy. You know, we are in the solar industry. We feel like our industry is growing and big and has a voice. But if we look at this tiny little segment of our US electrical provider, it is still the tip of the iceberg. The growth really started from 2010 to 2020, but solar has so much more to grow. And frankly, wind does as well. I don't necessarily see hydro growing, hydro or biomass really taking over in the renewable segment, because they have some other kind of ecological implications. But geothermal is also only 17 billion kilowatt hours. So geothermal is another very untapped potential here. So I want to just look at our 2020 renewables segment and say solar is really gaining. And storage isn't even really contributing to this visual, but the addition of storage is going to enable the further growth of solar. So how does the grid work? How is the grid set up? We typically have three of our largest grid operators are the Western Interconnection, the Eastern Interconnection, and the Eastern Interconnection also has MISO, the Mid Interconnection, and then the Texas, which is also known as ERCOT. So by having these three grids, these are all independent. So ERCOT cannot tap into any other distribution amongst the Western Interconnection or MISO or the Eastern Interconnection. So by having these segmented they're, it's good and bad. You aren't able to rely on any power sources from these other interconnections, but then you are also kind of supporting yourself. It's a localized sense of creation of power. And having a more localized sense of creation of power is a good thing because transmission and distribution are where the problems are coming with our grid today. 92% of all outages are occurring in distribution infrastructure or transmission. And these failure points are occurring due to aging infrastructure, severe weather events, and even vandalism, like if someone is affecting power lines. So we're seeing the need to spend on transmission and distribution increasing dramatically. So even from 2012 to 2017, transmission spending increased from 15 billion to 21 billion. And this is really because the access to clean energy and the need for reliability, security, and resilience is through strengthening transmission and distribution. In improving the reliability of these systems is tricky because these were installed so many years ago that they really need massive overhaul, and the grid operators don't necessarily want to invest in the improvement of this infrastructure. So how do we find solutions that work around the weak point of transmission and distribution? So just for fun, there is a website called poweroutage.us, and I encourage any of you to look at poweroutage.us any time of day. It's a snapshot of any given moment. So I took this snapshot a couple days ago. We can see that California and Florida, Puerto Rico's not visually displayed on here, but California and Florida are experiencing the biggest outages, with, in California's case, over 25,000, in Florida, over 11,000. Back in May, I want to say on May 4th, I was just looking at this website because I've been kind of scanning it over the past few months to create this slide deck. And there were a ton of outages in the Gulf Coast region. And turns out that Mississippi had a really bad severe storm. And there were approximately like 100,000 outages over the Jackson area and, into Alabama, Louisiana, etc. So on a national scale, we might not even hear about regional storms that are causing major outages, but they are still happening, and they're happening relatively frequently. The interesting thing is that most of the outages aren't happening from these kind of freak accident events, the big storms, Katrina, or the Storm Uri, Hurricane Sandy, etc. It's the smaller weather events like this one that happened in Mississippi last month is what's causing these more frequent and regular outages. So what can we do? And the first step is diversification. If you think about finance, you want to diversify your financial portfolio so that you can be hedged against any catastrophic risk. So we want to be using diversification of energy resources, distributed energy resources, as a way to provide resiliency for your grid so that you can have some level of backup. And battery projects really can provide this level of resiliency and diversification for the portfolios that we have today. In terms of solutions, the grid improvements can come from supply and demand side solutions. And I want to start by talking about supply side. So this is a snapshot from one of MISO's recent reports. And these are both future solutions. So what future one is already an improvement from whatever we're experiencing today. So this is a method of improving grid interconnections. And this article I recently read from Canary Media. Canary Media is the new green tech media. And improving interconnections, this is really the first article I've read recently about a grid operator wanting to strengthen the interconnections in a serious way. So kudos to MISO for putting this as a priority. And this is part of their long-range transmission planning effort. So I encourage anyone in any region of America to look into the Mid-Continent Independent Service Operators long-range transmission planning effort, because this is really a method to provide a stronger bulk power system with more reliability to be flexible based on the future energy needs of the region. Another supply side solution that I've recently learned about is a coal plant in Maryland is shutting down. But instead of just shutting down the coal plant, they are retrofitting to incorporate battery power. And this is the first coal to battery transition. When this happens, this is also supposed to go, this is the Talon energy provider, and this is at the H.A. Wagner plant. This is supposed to happen within the year. Battery power is going to be used 20 megawatt hours, or is it 20 megawatt battery, excuse me, not megawatt hours, online within this year. So this transition, coal to storage, if you will, hasn't really been coined yet because it seems like the first, but this is something that we can look for to take an existing power generating site and just transition it into a battery rather than needing to rely on a fuel-based solution. Okay. I see some people have raised their hand and there are a few comments, so we will address those shortly. All right, and to shift gears over to our demand side solutions. Automated demand response, also known as ADR, is a technology that's actually been around for a while. I was reading articles back to 2012 of this being relevant. And ADR is a way to have utility providers control variable frequency appliances. So Schneider and IP Keys are partnering to do this. And back in 2014, this partnership was able to demonstrate that variable frequency drives, which is a power electronic that is powered by a motor, can shift to frequency regulation signals that are given from a utility. And this is hugely valuable in order to reduce demand needs. So ADR is something that I think utility providers and building operators should start trying to communicate on and incorporate into their buildings, because it is enabled to load shift basically and shed the needs of these loads. And something other similarly is the relationship between the utilities and building users for something like refrigeration. Having a connectivity or a relationship between refrigeration and the utility really helps load shed. And another demand side solution that recently happened through Green Mountain Power is aggregating home batteries to provide frequency regulation. And this is new. They're trying it out. And I think taking these steps to scaling and aggregating home batteries in order to reach the frequency regulation is really an exciting next step. How can Soligent Solutions help you today? So this is an icon of a virtual power plant. And virtual power plants are a way that installers today can provide resiliency to the grid. And virtual power plants really are just ways to have all of your batteries aggregated and communicate to each other so that they can kind of share the load and provide need as needed or requested by a utility. And our VPP solutions, as of right now, are from Generac, the Power Cell, and Sonin with their EcoLinks product, our products on the screen. And then Enphase Storage really is working on so many different kind of firmware and software related improvements that I think that we're going to have some interconnectivity between Enphase products really soon. And the other good thing is that via the Enlighten app, you can view all of your different systems to make sure that they're all operating properly. So adding backup is really on an individual level a way to avoid the needs of improved distribution and transmission, because you're providing resiliency for yourself. You're kind of taking those matters into your own hands by backing up your own home rather than hoping or relying on weatherization or improvements on a utility scale solution. So we are kind of able to nip it in the bud and provide a solution directly from the homeowner. Oh, great. I love the little VPP animation. And that's it for today.